Okay, so let's have again this algebraic proof, and you'll see once we get started how simple it is. Okay, in theory it's just actually writing what you're doing. You normally just do the mathematics yourself without thinking about it, especially if you're doing algebraic expressions, equations and things like that. What you do in your head is what you've got to write down. So for instance, if you've got an expression or an equation where it's something like 3x minus 2 and you have to add 2 to both sides, well, now you added 2 to both sides. That doesn't change, but the only thing you have to do is write what you are doing. Okay, and that's the algebraic proof. Okay, the second one in your vocabulary is your two-column proof. Well, that's basically the same thing. It's where you're showing you're working out on the left-hand side, and you write what you're doing on the right-hand side. Okay, you can keep it as simple as possible, because you'll see in a few minutes you've got this key concept table where you've got, and it says, like the first one says, the additional property of equality. So long as you write additional, that'll be sufficient to get the points. Okay, so we'll keep that. So on this page you've actually got all the properties of real numbers, and you've done all of these since you've been at school. The additional, the subtraction, multiplication and division, you've used all the time you've been in school. All right, the reflective one is the one that students miss. It's the same one. Okay, think of yourself when you're looking in the mirror. Biggest example to do that is where you've got something like an equilateral triangle, and they put a perpendicular line down from the top angle. So now actually you've got two smaller triangles. Well, the line that you've dropped down, that perpendicular, is actually the reflective line. So that's the one that students tend to forget. So make sure you do that. Okay, and then you've got the four others, the symmetric, where A equals B, then B equals A. And then the transitive, well, the transitive is just like you've just been doing the law of syllogism. Okay, if A equals B and B equals C, then A must equal C. You should have that one. Okay, obviously you've got the substitution. You've done the substitution property many times before, and the same with the distributive. So let's have a look at number 1. If angle 1 equals angle 2, and angle 2 equals angle 3, then you can turn around and say angle 1 equals angle 3, and that is the transitive property. This is where you're actually doing. So let's have a look at example 1 that's in your book. Okay, as you can see, you've got negative 5 parentheses x plus 4, close your parentheses, equals 70, and it says then x equals negative 7. And here's where you're actually doing a two-step proof, and as you can see, it's all there. Okay, the first statement you ever come up against is always the given one. So whatever you are given to find, that's the first line you should write. Okay, and then obviously the last one is also what you have to find. So if it says given that this, this and this, find that, well, your last line will always be find that. So you're actually filling in the bits in between. Okay, and as you can see, what they're doing is obviously they're distributing both sides. They're substituting in the negative 5 times 4 for the negative 20. They're adding numbers together, they're substituting in again, then there's division, and then finally your answer. Okay, but again, it's exactly what you've done in the past. You've got all your algebra on the left hand side, but what you do on the left hand side, you must write about it on the right hand side. Let's have a look at question number 5. Okay, typical sort of question. You are given y plus 2 over 3 equals 3. You have to prove that y equals 7. Okay, so if you have a look at what you've got, you've been given this table. Okay, and this is the sort of thing that you will get in a test, where you've got a statement over here and you've got the reasons over here, Okay, whatever you do algebraically, you must write about it. So the first one's asking you for the given statement. So the given statement is just going to be y plus 2 over 3 equals 3. Okay, then if you look at the second one, you're multiplying by 3. So over here, so there's 1. Number 2 is where you're multiplying. Okay, then you've got number 3, and you've got nothing on number 3. Well, what do you need to do is you've distributed, so just get rid of what you've done on the left and the right hand side. So now you've got y plus 2 equals 9. So that's substitution. And then finally you've got the y equals 7, and that's the subtractive. When you get to question number 6 is asking you to write a 2-column proof to verify each conjecture. Okay, and you've got this question that says if negative 4 parentheses x minus 3 plus 5x equals 24, then x equals 12. Okay, write a 2-column proof. On the left hand side, do all your algebra to prove it first. Don't write any reasons, do your algebra. Once you've done your algebra, then go back and see what you did. The line above will tell you what you've got to write in the line below. So, what we got negative 4 x minus 3 plus 5x equals 24. Okay, so in theory that's given. Okay, so there's number 1. Number 2, where are we going next? He's going to do the negative 4x plus 12 plus the 5x, and that will equal the 24. Okay, we'll leave a gap there for number 3 is going to be x plus 12 equals the 24. Okay, line 4, you're going to have x equals 12. Okay, so that's what you had to do. So we've done all the algebra. Let's have a look at what we've got. So in line number 1, that was given. Okay, line number 2, what did we do? We distributed. Line number 3, we substituted. And line number 4, line number 4 was actually proving. So there's the proof. Okay, so do the algebra first and then come back and write on the right hand column what you did.